this was what I think was the hardest question on the entire 12A. This is question 16. The question states, the absolute value of 1 plus z squared equals 4, obviously over the complex numbers. Find the maximum value of the imaginary z, expressed in the form square root m over n, and find n plus n. And the choices don't really give you any options for elimination, so you're forced to do some sort of algebra. In the contest, I tried substituting z equals a plus bi. The problem is, you substitute it in and you get a fourth power equation, which you can't really solve. Although one of the official solutions did do this, and they did solve it at the end. But the way you want to solve this problem is actually quite ingenious. First, you want to actually complete the square within the absolute value. So you get this. And since we are trying to find the maximum value of the imaginary value of z, we can let w equals z plus 1/2. And since this is only a difference of a real number, the imaginary part of z is not changed. So realistically, we just have to find the imaginary value of w. So now we can substitute it in. We have w, this is squared, w squared plus 3/4 of the absolute value equals 4. And in the complex plane, this is a circle centered at negative 3/4 with radius 4. And we're trying to find the maximum value of w squared. So this is the square, this is the locus of w squared. When we take the square root of this, the length, so the argument of w does not change. The argument of w is the length, which would just be square rooted, but the angle of w, because we want the maximum imaginary z, so we want w to be as high in this direction as possible, which means we want to choose w squared so that it's right here. So then we have w squared equals negative 3/4 minus 4, and then we solve for w. Solving for w, you get square root 19/2, and then the answer is
I kind of regret not checking out the last couple of questions because I couldn't really get a feel of how those were. This one seemed decently difficult.
Yeah, it's pretty interesting that they put like,
especially for a question 16.
Yeah.
So the funny thing is, in this question, just remove the absolute values, you can actually get the right answer.
Oh wow!
Which is kind of
I think that's probably
obviously you add the negative sign out of everything, you would get the right answer. Now that's
kind of odd.
Kind of a cheap way, but this is why they couldn't put this question as 22 or 23.
Right.
Because there's this method.
Yeah.